Thank you for joining today's talk. We'll learn how to generate insights from Omics data using our flagship product, Omics Data Manager. After the talk, hopefully you'll have a better understanding on how to access integrated standardized data using ODM, query data at scale across studies and data modalities, as well as build flexibility visualization applications. Before jumping in, I would like to introduce myself and Genestack. I'm Qian, Solutions Consultant at Genestack. We base in Cambridge, UK, and work with both small and some of the largest organizations, including Roche, AstraZeneca, Unilever, and Corteva. Our flagship product, Omics Data Manager, is a culmination of our collaboration with industry leaders. It is the best in class for omics data integration, metadata management, and search. We also provide professional services and consultancy to our customers. So what is ODM? It fills the gap between data lake and visualization application. On one end, data lake is like data standardization, data lineage, and metadata management. While on the other end, visualization application tends to suffer from incomplete and low quality data. ODM addresses this gap by providing single point of truths to structure and standardize different data types, and an integration layer to capture the relationships, as well as various tools to curate and validate metadata. In day-to-day life, as data scientists, you may face three major typical challenges. For example, how to access integrated and standardized data, how to query the data at scale, how to build flexible visualization applications. Most of us data scientists have experience in trying to get integrated and standardized data, but it's not always a very easy task to do. Very often, data sits in multiple systems. For example, proteomics data and genomics data, they live in different databases. While the relationship between different data types is incomplete, and metadata standards are not unified. ODM helps to integrate multi-omics data from different sources in one place. As you can see here, this is a snapshot of the study browser in ODM, which allows users to explore and search multiple studies and their relationships. I'll pause here and give you a quick demo of the study browser. Once you log in, the dashboard will give you multiple links for documentation and features within ODM. For this demonstration, we'll go directly to the study browser. As you can see here, all the studies under my account are showed in the study browser. Also, you can use different filtering functions to select the study of your interest. I can select use based on the user and groups, as well as data types, study sources, study descriptions, and in addition, you can search for metadata information like lung, liver, or cell types. In addition, you can also search on the top bar of the study browser. You can just type in, for example, TCGA, and a list of studies related to TCGA will show up in the browser. I'll click to this TCGA lung adeno. This will give you the metadata editor, which you can view all the information about the study samples and different experimental data you store in this study. A unique accession number will be assigned to the study, and you can input some basic descriptions of the study. And this is the sample table where you can view all the samples within the study. Due to the time limit, I'll stop here, but welcome to book a one-to-one session with us for more details demo. As mentioned, the second challenge in data science is how to query data at scale. General purpose technology, such like Sparks, is very expensive, and it is not always the best choice for all data types and use cases. For example, we have performed superior performance on genomic filtering and associated studies on a single machine compared to spinning up a large Sparks cluster. Also, the second issue, which can block querying data at scale, is the trade-off between flexibility and scalability. Different database technologies has their own limitation either on flexibility or scalability. Some, for example, graph databases, is good at handling and querying complicated relationships, but doesn't scale very well. Also, if you're a small or middle-sized organization, it is not possible to have all the resources to set up the infrastructure and analytical capacities with a big upfront cost. ODM's unique technologies, single point of truth, integration layer, and integrated APIs can easily resolve those issues. To ensure scalability, we also apply different technologies and optimize them to the specific data types and user cases. The third challenge, as we mentioned, is how to build flexible visualization applications. Very often you find it's really hard to modify or evolve big applications developed previously. Also, they might not be able to integrate with latest data science packages, for example, from R or Python libraries. Or it's hard to scale up against new data types, such as single-cell and population-based data. ODM offers integrative APIs, which allows users to edit, link, and query any data within ODM. Here is an example of an API-driven visualization using RShiny. And as you can see here, you can use one data scientist within a day to process 200 cell types and 6 million cells. I'll pause here and give you a quick demo. This is the RShiny app I have just shown you. It will allow you to perform both bulk study and single cell study for RNA sequencing. We'll choose bulk study. And also I'm interested in immunology area. A list of study under immunology category will show here. I'll first choose the first study. And I'm interested in a T-cell marker CD3E. As you can see, both proteomics data and RNA sequencing data has been shown here in the plot panel. You can also find information about the gene, study, sample, expression. I think more interest thing for data scientists will be, you can see all this has been processed by 3 API calls. So you have filtered the study under bulk study, and therapeutic area is immunology. And you filter the data from this particular study using the accession ID. Apparently, you can query more genes, for example. And it's really quick to query the database using the API calls. I can further filter the data using lymphnode. For lymphocyte cells, and it's still 3 queries, you generate all the inquiries and the plot. Apparently, you can do filtering using, for example, I only want RNA-seq data. So the plot will show only the RNA sequencing results for the genes of interest in lymphocyte cells. And all the queries has been done with 3 API calls. I would like to close today's talk to welcome you, to encourage you to join our industry collaboration. We understand how difficult and challenging it is to build a data landscape. Therefore, we encourage to build industry standard solution through knowledge and cost sharing, where we'll strategically avoid any pitfalls and accelerate development. Our current interests are focusing on single cell and clinic omics data integration. It is an exciting time for us and an opportunity for you to join us on this journey. I would like to raise your attention to the talks. Kevin, our head of data science consulting, will give a virtual talk in the track of data and metadata management on how to build a more integrated and scalable omics data landscape. And also there is another talk tomorrow on how to integrate omics and clinical data. You can also book one-to-one session with us through our virtual booth. Thank you for joining us for the talk. You can contact us through info@genestack.com.